Good morning, KubeCon and CloudNativeCon. Welcome to 5 Simple Steps to Simplifying Your Compliance Journey with a Service Mesh. I am your host, Granville Schmidt, and I am the lucky presenter to be the second to last person standing between you and what you're really waiting on, lunch. Before we get started, please note there are 2 exits in the front, 2 exits in the back, so if at any time you're super excited about implementing a service mesh in production on a Thursday morning, and you cannot wait until after this presentation, please make your way to the aisles on your left and right, and I'll meet you after the show. Now sit back, relax, and please be interactive through the presentation. Today's agenda, we're going to learn who am I. We're going to have a brief security review of monolithic microservice architectures just to pave the way to where we're going. We're going to learn about what a service mesh is. We're going to go over the Istio architecture, and we're going to learn how to leverage Istio to help simplify your compliance requirements. As you know, my name is Granville Schmidt. I am the Site Reliability Engineering Lead at Aspen Mesh. Previously, I've served as an Information Security Officer, Chief Technology Officer, Head of Site Reliability and Security, and Principal Architect. And you can follow me on Twitter at Granville. Quick thing about me is I absolutely love regulations and standards. By raise of hands, who loves regulations and standards? All right, there's a few of you. That's more than I thought. Well, we kind of have this preconceived notion that there's this thing that's slowing down our velocity, right? We all want to work on value-added features. But as it turns out, when we neglect to understand the regulations and standards up front, we actually slow down our velocity as we actually progress through our delivery pipeline. By doing it at the beginning, we're able to understand what we can work on now, what we can wait till the end, and actually help increase the velocity over time. What do all of these regulations and standards have in common? There's 5 common technical requirements that you'll find throughout them. Oh jeez, all right. So the first one is authentication. So we need to verify the identity of the actor making the request to protect the data. Second, we have authorization. Authorization is the verification of the actor to make sure that they're allowed to access the requested data. Accounting. Accounting you'll hear is synonymous with auditing, but it's really the mechanisms for recording and examining the activities within your system. Next up, we have data integrity. How do we go about protecting our data from being altered or distorted in an unauthorized manner? And last, we have record keeping. Keeping record of system architecture, data flows, and processes. So we're going to take a step back real fast, and we're going to go to a monolith. I know we're all here for microservices. I know we absolutely love them, but we're going to take a step back. Anyone interested in 2001: Space Odyssey? Yeah, let's get it. Yeah. So, from a high-level point of view, we're going to, let's take a look at the monolithic architecture. It's like a 50,000 foot view. So we have encrypted client traffic going into a load balancer, and then split up between our 2 microservices, or 2 monolithic services, that compromise of authentication, authorization, our business logic, and data storage logic. Within each, we have logging and perp monitoring. It's easy to do, right? We're able to do line by line and logging within it. We understand the data flows. It's just easy to build out your audit logs internally. But ideally, this architecture is still not compliant, right? So we want to get to this state where we have encrypted traffic going into our load balancer from the client and then into our monolithic microservices. And this is relatively easy to do in a monolith, right? We can just build out some certificates, bake it into our monolith, and away we go. Then there comes a time that we all know as the split. The split's an interesting time. It's where we take these monolithic architectures and we start breaking it down into the microservices to help increase business agility. So we take the monolith that we know and we create it into something like this, where we have have the encrypted client traffic going into a reverse proxy. We have our decomposed microservices that used to make up our model. And now we move authentication authorization from in the code base to normally the reverse proxy. You can also have it in this. And then we also have logging per monitoring each. But the interesting part is this, right? We have this unencrypted service traffic internally. And this is where it gets really difficult to actually secure and ensure compliance. Because what normally happens in this is that we need to build out some type of certificate management to do this encrypted communication. And this involves us baking certificates for every service. Anytime we have new services in the flow, guess what we get to do? We get to bake them again. And you know what? What happens in most regulations and standards? We have to rotate these on a regular basis. Who in here loves rotating certificates manually? Not me, yeah. So we need to accomplish this, but this is hard, right? This is really hard. If you have the resources, you can go ahead and build these systems internally, and it'll work effectively, but it takes a lot of time to build this securely and prove to auditors that it works as anticipated. The rise of the service mesh. So, by a raise of hands, who in here currently uses the service mesh in production? Who absolutely loves their service mesh? All right. So once upon a time, a service mesh was born. So for those of you that are currently using a service mesh in production, a service mesh is really a way to abstract out a lot of the non-product features into more of a centralized place that provides policy management across the board and helping ensure the traffic management of your microservices. You would primarily use a service mesh to really, let's imagine all the time that we spend working on non-product features, right? So this is all the manual toil, like how do you build out all of your tracing internally? How do you build out all of your logging and audit logs? How do you go about building the resiliency of your microservices, right? It used to be that once a call came into your monolith, you had relative reliability internally on how it works. But once you spread this out into multiple microservices, you introduce a lot of new challenges, right? So we have to do things like retries because of network failures, encrypting the traffic from service to service, or just a couple of the different use cases for it. And how do you use a service mesh? This really depends on the service mesh that you're implementing, and today we're going to be talking about Istio. The Istio architecture overview. So, Istio consists of a control plane. This is going to be managing everything that's related to our service mesh. First off, we have Pilot. Pilot actually handles the configuration and sends it down to the Envoy proxies. So, by raising hands, who understands the sign of the car pattern? All right, so I don't need to explain this. But for those of you that don't, so the sidecar just controls inbound and outbound traffic. So instead of you having to build in a common library across all your microservices that handle all the requests and building out audit logs and tracing and mutual TLS, this sidecar handles all of that for you automatically. In fact, in Istio, this gets injected at runtime. Next, we have Mixer. Mixer is responsible for policy and telemetry. This is a very interesting piece for this audience and what this presentation is about. So with Mixer, we're able to actually handle multiple different policies that control mutual TLS, authentication and authorization, and handle all the telemetry that comes out of our services. Citadel, a personal favorite. Citadel is the key management service within Istio. It is responsible for handling all the TLS certs and actually sending it down to the Envoy proxies, so you no longer need to bake these in yourself. Galley handles configuration validation. When you deploy Istio to your production cluster, it's the one that ensures everything's going to be correct. Sidecar injector, this does all the fun magic for you. You don't need to include the Envoy container in your deployments. Instead, you let the sidecar injector inject this in there for you. And lastly, we have ingress gateway and egress gateway. These are amazing. So this handles all the ingress traffic and egress traffic. And when we talk about compliance and regulations, egress is key, right? We need to ensure that none of our services are talking to things that they shouldn't be talking to. So how do I leverage Istio to address my security and compliance requirements? Before we get there, we're going to go to a story. So, a few months back, I was sitting on the couch watching the brand new Escape Room movie. Right? Who's seen this movie? Yeah, it's really bad, wasn't it? But I was fascinated. I like this concept. I'm a puzzle solver, right? Like, as an engineer, we like solving puzzles. And I was watching this movie, and I was like, wow, this would be really fun to do. I knew there was this big explosions of escape rooms across the world, but I've never done one. And so I'm sitting on the couch, I pause the movie, I book one 3 hours later. After doing my first one, I booked 3 the next day. And if all of you that know me, or don't, when I start doing something, I go all in. Next weekend, I did 7 in one day, 8 in the next. And, throughout this experience, I really enjoyed them a lot. And I was like, man, this would be really fun to actually build an escape room, right? Like, building these puzzles for other engineers to solve and find their way out of rooms. I was like, what better time than KubeCon? So KubeCon, your mission, should you choose to accept it, is to leverage Istio in providing clues to implement portions of the common technical requirements found in standards and regulations for a top secret healthcare application without writing code. This message will be removed in 10 seconds. Good luck. Our top secret application. This is the universe's most advanced patient check-in application. UMAPCA. It's glorious, isn't it? 3 services, what is that, 9 endpoints, and this is complex. And up here we have this cloud database service. So what we're going to do is we're going to review this, and we're going to start leveraging Istio to actually secure it and help ensure compliance. Does anyone see any issues up here or anything scary that stands out? I like it. Anyone else? What about these deleted points? These are pretty sweet, right? Nothing like deleting patients and employees. Clue number 1. Dance like no one's watching. Encrypt like everyone is. Anyone have any idea what we're about to do? If you guess encrypt traffic and ensure non-repudiation for request, you guessed right. So ideally, we want to encrypt the traffic between these 2 services. And actually all 3 services for that matter, but this is simplified. We're going to do so via mutual TLS with Istio. By show of hands, who understands mutual TLS? Awesome. For those of you that don't, the idea is that we're actually building certificates on both sides that acknowledge the other recipient, and they can just, they trust each other. So first thing we're going to do in Istio, we're going to create a policy for the recipient. And this recipient is going to be the patient's receiver. And what we're going to do is we're going to actually pass it a target of the patient service, and then we're going to pass it this peers. What this says right here is that it's going to be strict. And strict mutual TLS means that everything talking to it must be authenticated. On the other side, we have the destination rule. This tells everything else inside of our mesh that when it talks to our patients in the top secret namespace, that it must use mutual TLS. So let's step back real fast. So beforehand, we had this really awesome pattern where we manually baked certificates from our CA, put it into our deployment pipeline, restarted all of our services, and deployed it. It was fun, right? Now we just deploy these two YAML files to production, and we just accomplished just that. And by the way, these certificates rotate automatically for you. So when we talk about the common technical requirements, we just really started taking care of the authentication piece and a little bit of the data integrity piece. Because by having encrypted traffic end-to-end, we avoid data from being altered or compromised once inside of our network. Clue number 2. Trust is key in relationships, not for service-to-service communication. Any takers on what we're about to do? Again, if you guess this correct, we're going to enable service-to-service authorization. So currently in our microservice architecture, we have the check-in service talking to the patient service, the admin service talking to our patient service, and this check-in service deleting employees. That sounds really fun. This isn't acceptable, right? We get in this habit when we start building these microservices. This is normally the last thing that we think about. We're trying to push out all these features, and like code reviews can help ensure that code isn't malicious inside of our network. But if things get inside of our network, this can happen really easy. So what we need to do, we need to accomplish this, right? Check-in service should not be authorized to talk to the admin service. And to do so, we're going to be creating a cluster RBAC config. And we're going to set the mode on for the namespaces of top secret. And what this really does is that it says without authorization, without explicitly authorizing services to talk to each other, they're going to be denied. We deploy that out. And then we create a service role. The service role for the patient's viewer in the namespace top secret says that when whoever's going to get this role, when they go to /patients, they can only do get and requests. Service role bindings. So we have this role, and we need to actually assign it to someone. What we're going to do here is that we're actually going to bind the patient viewer role to the subject of the check-in service account. So the check-in service has a service account in Kubernetes, and we're able to say that this service account, when the properties of the originating request come in and they have the role of receptionist. So this is going to be a receptionist at our front desk. We want to ensure that not only did the request come from the check-in service, that it also came from someone who was authorized to make the request. Next up, we have taken care of authorization and data integrity. So when we verified the actors allowed to access requested data, and beforehand we encrypted the traffic end-to-end and made sure that it was non-repudiated, we were able to account for authorization and data integrity. If a user performed an action and it wasn't logged, did it really happen? Log all access. Any takers? That's right, we're going to collect access logs and distributed traces. So we have our check-in service and our patient service. What we need to do is we need to ensure that all requests we have access logs, and we actually capture all of our traces. So what's interesting is the access logs are critical in every regulation and standard. We need to have proof that what happened actually happened, right? When we have security, it doesn't mean it's compliant, and compliant does not equal security, right? So we need to have proof for everything that we do. If there's no proof, it doesn't matter in the eyes of the auditor. So we need to enable access logs. We're going to do so via a couple of different methods. So first off, this is for the Helm chart, but the same stuff exists across the board for if you're going to configure it manually via just a normal manifest. We need to configure the global proxy access file to standard out. And what this is going to do is going to allow us to actually grab these via our normal logging mechanism. And then we can actually, spread that out into a SIM or what other system of choice. We can set the access log encoding to JSON or text. Depending on your system, it may be easier to parse it in text or JSON. Use what's appropriate for your business. Next, we can actually build out the logging format. If you leave it as blank, it just includes everything, but you can actually customize this to your needs. Next, we can set up the tracer type to zip pin, and then we can actually pass the address of where it needs to send the traces. And once you've actually configured this, you deploy it, and you just magically got all access logs and distributed traces across the board. So instead of you manually having to go out libraries and actually send them off to another place, it's automatically done for you. So now we have authentication, authorization, accounting, and data integrity. Control outbound data before it controls you. So let's take a moment. So when we talk about the regulations and standards, who here understands every single outbound call that's happening in their microservice architecture? Yeah. Wouldn't you love to be able to explicitly grant that access without going through some other external means? Wouldn't you love to be able to show your auditors a centralized configuration that proves that it's only talking to certain services? Well, with Istio, we can enable egress control. So when it comes to HIPAA, we need to ensure that we are only talking to HIPAA-compliant database services or HIPAA-compliant services. And, as organizations, we switch to microservices to achieve agility. And, we tend to go fast, we want to implement features fast, but when the auditors are around, if you send it to a place that wasn't HIPAA compliant, the fines are ridiculous, and you really don't want to pay them, nor do you want to compromise anyone else's data. So, with this here, we can actually enable the outbound traffic policy to register. And this is key to note. By default, outbound traffic policy, it actually allows all right now in Istio. So you need to explicitly set this on installation time. And what this means is that only the whitelisted services that you explicitly defined are allowed to talk outbound. So first off, we're going to whitelist the egress. We're going to create a service entry called the HIPAA compliant DB egress, and the namespace is global. We're going to pass it in the host. So this is the HIPAA compliant DB provider of choice.com. It's a great service. I love it. And we're going to configure what port it's talking to, protocol that it's using, and that it's a mesh external. Next up, we need to create a virtual service where we actually specify, again, where it's going, the ports, and the route that it's taking. So, life is a journey. For this last one, I spent a lot of time thinking, right? So, we've done 4 simple steps this far. And this last one was complicated for me. There's so many amazing features in Istio, but I felt like it wasn't fair to give you a step 5. In compliance, it is not a one and done situation. And security is not a one and done situation. It is constantly evolving. But by taking all the foundational needs of Istio and building on top of it, and building your business processes on top of it, we're able to better ensure security and compliance. Secure is not compliant, and compliant is not secure. If there's anything I want everyone to leave here today, this is it. We tend to start thinking of security first sometimes, and sometimes we think about compliance first. Neither one of those is correct. It's so easy to build out a secure system, but when we talk about regulations and standards, unless we can prove it, it doesn't matter. You could have the world's most secure microservice architecture, and unless you can show the auditors and everything to prove otherwise, it doesn't matter. And vice versa. If we go through the compliance idea and we start checking out boxes, your system's not going to be secure. Compliance, regulations, and standards really provide a foundation, some ideas to build off of. They're mandatory things that you need to build, but they're not a means to an end all. So just make sure that you take both into account, all right? So achieve what you need to achieve through compliance, but please don't stop there. And please don't stop with security